Alright, so here are some generic terms you should know when you are talking about sets. We use some symbols, and you need to know the symbols and their meanings. Alright, so we have this first one, P equals to ABCD. What is simply telling you is that P is the set ABCD. Alright, so P is a set, and the numbers inside the set or the elements in the set are A, B, C, and D. So anytime you see P, it's like they're telling you, oh, P contains A, B, C, and D. P is the set. Alright, and then when you see this next sign down here, this sign or not something like it means an empty set. That means there's nothing inside that set. That set contains nothing. It's an empty set. Alright, this one that looks like letter E, alright, or sometimes they use U, it refers to a universal set. That is the big set, the main set. You can think of something like in a school, you can have different sets. You can have grade 1, grade 2, grade 3, but all together the entire school is the universal set because it contains every set. Alright, so the next one is this E. Alright, so when you see this, what it means is that that thing is a member of something. So you can see something like this, P E U. What this means is that P is a member of the universal set. You understand? Or you see X, E, Y. It means X is a member of the set Y. Alright? So that's what E means. And then when you see an E that is stroked this way here, it means it's not a member. Alright? When you see letter C, it means a subset of something. So if I can say P, alright, I can say P is a subset of the universal set. Alright, so what that means is that P is a set on its own that is inside the universal set. Alright, why this letter E? E stands for a single member. Alright, so as we solve further, you will see some examples so you understand very well the difference between member and subsets. So, but you can always think of it this way. I like to use the example of a school. Alright, so universal set is like the entire school. A school can be called the universal set, universal set. Then the subset can be the grades, grade 1. Grade 1 can be called the subset. And then a student, a particular student, just one student can be called a member. E can be called a member of this subset that is inside the universal set. So that's the way sets are. It's just about arranging things, grouping things in the right order. So when you also see this letter C facing downward, this backwards, it means it contains something. Alright, and then these are two of the ones we use commonly: P union Q, P intersection Q. So P union Q means if you have sets P and Q, you join them together. Everything in P and everything in Q, join them together, add them as one. Alright, that's union. And then for intersection simply means look at P and Q. What is common to both of them? That is intersection. Where do they meet? Where are they common? That's intersection. And then NS means number of elements in S. Alright, so you would understand these things better when you see us using it to do examples. So when I solve some questions having this, you would understand better. So look at this question now. You are given, let's say, question 1. You are given this question that says 9 dash, and then you are given this set 2, 4, 6, 8, 10. You are told to fill in these missing spots here. Let me erase this. So you are told to fill in these missing spots. This one here. So what is going to be here? Is it going to be, the question is telling you to pick from either E or E with a stroke, which means either a member or non-member. Alright, so if you look at this question, they're asking you, is 9 a member of this set? Let's look at it. 9, can you see 9 here? No. So 9 is not a member of this set. So the correct answer is 9 is not a member of the set. 9 is not among the numbers in the set. It's as easy as that. Alright, so let's look at another example. Let's say 45. So 45 dash 5, 10, 15, 20, dot to 100. All right. So when you have something like this, what does it mean? All right. When you have something like this, it means to 100. It means these numbers continue in multiples of in increments of 5, 5, 5. So is 45 a member? The answer is yes, because if you keep going from 20, you get 25, 30, 35, 40, 45. So 45 is a member of this set, which means in this case I will put E, meaning 45 is a member of the set. So set is just about understanding, looking at what you are given and looking at what you are told to place it. Can I place it inside here? If yes, use the correct term. All right. So that's how to know when something is a member of a set or not. You understand? So I can also put something like this. Let's say all right. So I'm giving this question. Dog, is it a member of this set? First of all, what do we have? What do these sets have in common? That's what you need to ask yourself. What do they have in common? They are all animals, ain't they? So is a dog an animal? The answer is obviously yes. So a dog is supposed to be a member of this set. I forgot to put the ellipsis. What this ellipsis means that and so on. So the set is endless. There are more items in the set. Alright. So dog definitely is one of them. So that's how to know if something is a member of the set or not. So it's that easy. So also you can be told to, you are given a set and you are told to write a subset. If I give you a set, for example, 1, 2, 3, 4, and I tell you write the subsets of this set, what's the meaning of subsets? So it means like, oh, this is your main set. 1, 2, 3, 4 is your main set. Write the subsets. The subset is 1. 1 is a subset. 2 is another subset. 3 is another subset. 4 is another subset. As easy as that. It's like taking this set as an entire school and you are told to group it into classes. So this is just it. These are subsets. All right. So another thing they could have told you. This question asked us to write the write it as subsets. Another question could have told you to write it as the members of the sets. So what are the members of this set? The members of this set would have simply been 1, 2, 3, and 4. So sets are very easy. All you need to do is to understand what is contained in that set and then ask yourself if the one you are being asked to represent, is it a member of that set? So that's basically what it involves. So let's now go deeper into some other examples of sets, which are union and intersection. All right. So union and intersection. I have previously mentioned what union and intersection mean, but an example will help us to understand it better. So let's say you are given a universal set, all right, which has these elements, all right, and then you have a set A, which is a subset of the universal set, which has these elements, and then you have set B, all right, you have set B, which is also a member of the universal set, which has these, and then you are told to find A union B. What does A union B mean? A union B simply means the elements in A, look at them, the elements in B, look at them, and add them together. Like, when I mean add, I don't mean plus. I mean write everything you can see that is in A and also in B. If you look at A, I can see 1. I don't care if it's in B. As far as I can see it in A, I will write it. So the element of A union B will be 1, all right? And then, can I see 2 in any of them? No. But I can see 3. They both have 3. So I'll write it 3, but just once. I don't need to write it twice. 3. And then what else? I can see 4 in B. So I'm going to write 4. So the elements of A union B are what? 1, 3, 4. It's as simple as that. All right. But if I was told to do A intersection B, so you see intersection is like an upside down U, like a letter N. So A intersection B means look at the set of A and B. Do they have anything in common? If you look at it, you see that they both have 3 in common. So that 3 that they have in common is the answer for intersection. Just 3 is A intersection B. So union means you look at both of them and you pick what is common, all right, to both sides. While intersection is picking what they both share in common, all right. So union, you pick the two of them, you combine it, but intersection, it's only what the two of them share in common that you pick. So look at this particular example. Sometimes in sets, you are not given all the numbers written like this in English. The universal set, they might want to confuse you, and they will just give you something like this. They will tell you that if the universal set U, all right, is all even numbers from 2 to 20, and then M is equals to multiples of 6 less than 20, and then L is equals to the even numbers less than 14. Find A, M union L, and B, M intersection L, and then C, U intersection L. So look at this question. You see that we are not really giving the elements of the set. They did not spell it out for us, but they told us what they are. For example, for set U, we are told U is all even numbers. U represents universal sets, obviously. All even numbers from 2 to 20. That is what U is. So we are going to include 2. So let's write the set. For all the even numbers from 2 to 20 are 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Alright, now we have the set of U. What about M? We are told that M are the multiples of 6 less than 20. So M are the multiples of 6, numbers that 6 can go into. Let's go 6, 12, 18. We cannot go further because the next number will be more than 20. And we are told that it's multiples that are less than 20. So we have gotten our M. What about L? L is what? Even numbers that are less than 14. So any even number less than 14. What are the even numbers less than 14? Let's think of them. 2, 4, 6, 8, 10, 12. I can't go more. Once I write, the next will be 14. So you see that this question, we are the ones that had to bring out the set from the question. And now we can use it to solve. Alright? So let's look at the first question. It says find M union L. M union L. Which means these two sets, I'm told to unionize them. How do you find the union of two sets? Simply, all the numbers they have together, all the numbers that they have, write it. Alright? Even if it appears only in one place, write it. So what will L option question A, what will my M union L be? Let's write all the numbers starting from the smallest. What is the smallest number I can see between M and L? What is the smallest number I can see? Smallest number I can see is 2. After that, I see 4, I see 6, I see 8, I see 10, I see 12, I see 18, and I don't think I'm missing any numbers. So that's my final answer. Remember, union, just simply look at the two of them, add what is all of them together, alright? But don't repeat 1 2 times. That's union. Then for intersection, M intersection L, intersection is very easy. Look at the two of them. What do they have in common? Are there any 2 digits of numbers, 2 elements of the sets that they both have? I can see that they both have 6 and 12. I can see 6 this way, up and down. I can also see 12. That's the only number they have in common. So it means that the members of this set will be only 6 and 12. That's the answer. And then the last one says U intersection L. U intersection L. Alright, so what are the elements that belong to both U and L? That's what the question is asking. What are the elements that belong to both U and L? So if you look at it, the U is a universal set. It contains all the elements you can think of, but L only has a few. So what are the ones it has in common? It's basically, if you notice, U intersection L will basically be the same thing as L. Why? We are looking for what is common to both of them. So anything that L has, U will have it, because U is a universal set. It is like the parent set. So everything that is in L will definitely be here. Alright. So if you keep looking at the both of them, you will notice that what they have in common for U intersection L, what they both have in common, if you count them, you see you have 2 here, we also have 2 here, 4, 4, 6, 6, 8, 8, 10, 10, 12, 12. So it's basically the same thing as L alone. Alright, 2, 4, 6, 8, 10, 12. That's the answer. So anytime you see the universal sets intersecting with any sets, you know that the answer will be that smaller set. So this is just a brief introduction to union, intersection, and the main terms we use in a set. The deeper we go, the more the examples I'm going to solve. Thank you for watching this video.